All right, Dr. Engelman, thank you so much for joining me today. I am looking forward to diving into this question with you because I think it's a fun one for the two of us. I want to talk to you about gluteomorphins, prodynorphins, casomorphins, the orphins. So on Cyrex array 3X, two of the analytes, well, for IgG and IgA, are gluteomorphin and prodynorphin. And then on Cyrex array 4, we have casomorphin. So I would really like to ask you, or for us to dive into, what are the orphins, right? What are they? How do we make them? How do they interact with the brain? What are the associated symptoms, if that's known? If this comes up, if the antibodies to these proteins come up, do they need to be permanently removed? So if somebody's only marker on array 4 that's positive is casomorphin, does dairy need to be taken away forever? Do we know that? Can we say that? Does it depend on the diagnosis that the person has? Let's talk about the orphans.
So the orphans, the article that you and I have looked at is the best thing I've seen. I love this article.
Okay, so I'm going to link the article for anybody that's watching this video or listening to the audio. The article is linked below.
Perfect. And the reason I like it for a lot of reasons. Number one, it came from a mainstream journal, research journal, which is the International Journal of Environmental Research and Public Health. That's not for kids, right? That's a real journal. And, there's fluff journals and there's real journals. Yeah. I like the real journals. I'm not a fluff guy, and neither are you. So, and the person that wrote this article is well regarded, but the research on this article is unbelievable. But it has to do with, the title is Casomorphins and Gluteomorphins have diverse systemic effects spanning gut, brain, and internal organs. And what it boils down to is that we have a couple things. Number one, this concept of foods. We've known about opioid receptors for some time, although we're learning more and more about the different opioid receptors. Some of them are, make us feel better. Some of them are inflammatory. Some of them cause oxidative stress and so forth and so on. And so, which was news to me, to be honest about it. I thought they were all opioid receptors, all just calmed us down and made us not feel pain. But evidently it's a lot more than that. And it turns out that these opioid receptors are in pretty much all tissue. They're definitely in the nervous system, but they're also in the gut and in the pancreas and in the spleen and in the liver and so forth and so on. So they're pretty ubiquitous. And when they're stimulated, it's interesting because it reminds me of Graves' disease, right? So Graves' disease is thyroid stimulating hormone receptor antibody, right? And so you go, well, that's an antibody that sticks to the receptor. So it must mean that you're not going to make thyroid, right? Because the receptor's got an antibody stuck on it. Well, it's the opposite. In fact, it activates that receptor, and that's why you get Graves' disease, because you don't shut off your making thyroid. And in some cases, an antibody that either fits on something that then goes to a receptor will stop that from happening, like TNF alpha blockers, right? Which are used for autoimmune diseases, arthritis, and so forth and so on. Or they may, in fact, activate that receptor and make it do whatever it's going to do. When you're talking about opioids, usually it's probably the fact that it's going to activate that receptor. And whatever the downstream effects of, there's a mu and a kappa and a delta receptor, you're going to have effects related to that receptor being activated. So it turns out that these are opioid receptors. And in this particular case, everybody knew if you gave somebody, a shot of morphine, that activated their opioid receptor. But what they didn't know until pretty much which is amazing to me, is the 1970s. Do you remember reading this? It's the 70s and the 80s. They didn't realize this opioid stuff from foods, milk and gluten till then. They knew about celiac disease in the 50s, but that's not opioids. This is actually foods that are broken down, parts of foods that are broken down that make peptides that actually fit that opioid receptor. And it turns out that there's a number of them, but the two that are the most talked about now are the casomorphin and the gliadorphins, they call it, or gluteomorphin. Similar, but not the same, but similar. And they, as this article says, they like to hunt together, which is a good one, which is why people talk about going off of dairy and gluten. But they're basically, in the case of casomorphin, which is the one that I'm the most interested in, is particularly from this article, is that it's a breakdown product of casein, beta casein, which is in all mammal dairy. So it's broken.
So both of those, with gluten and casein, both of those proteins, which are several hundred amino acids in length each, we're supposed to be able to break down proteins into individual amino acids or dipeptides in the digestive tract. But those two proteins specifically, because they're both proline rich, it's not possible for human digestion to break them down into individual amino acids or dipeptides. So we cleave them into these chunks, which are multiple amino acids in length. So for gluten, one of those chunks, or for gliadin, one of those chunks can be this gliadorphin or gluteomorphin, which is this opioid compound or receptor compound. Is possible for it to dock on the opioid receptor. And then the same thing with casein, that one of these breakdown products of human digestion of the whole casein protein can be this casomorphin. So it's a product of digestion. It's a broken up piece of chunk of casein, and it can dock on the opiate receptor.
Correct. And in some cases, it can cross-react, like casomorphin can actually cross-react with another peptide, particularly in pancreatic cells, which I didn't know, that has a similar, it's got a similar group of amino acids. So it can actually cross-react with that pancreatic peptide that helps create in the islet cells of Langerhans that actually create insulin. So that may be, you may have the downstream effect of activating the opioid receptor, and then in some cases, these chunks have amino acid arrays that look similar to other things. So now you got your cross-reactive stuff we talked about before, and you start reacting to the precursor of making insulin in pancreatic cells. And it used to be, what's interesting is, I thought was interesting, is you're supposed to digest all this stuff's supposed to be broken down in the lumen of the gut. But it turns out that the more gut damage you have, one, because you won't break it down because your brush border is what makes the enzyme that breaks it down. So if you have damage to that, or you have leaky gut, the casomorphins and so forth will not only hang out outside in the lumen, but also get into the bloodstream and then go everywhere the bloodstream goes. And so that adds to the idea of, if you want to look at problems, you got the casomorphin, which is its own problem. And then you got the idea of, well, how does it get even, I wish I would digest it down and it wouldn't stay one of those opioids, but at least it's out in the, in the lumen of the gut. Oh, no, it isn't. It actually got across a leaky gut, and now it's actually in the bloodstream and going to all these different receptors all over the body and creating havoc. So it's a big deal of what is the integrity of your gut barrier in terms of not just its own problem, but what else besides things like lipopolysaccharides are getting across that barrier that you don't want there. And this is definitely one of them.
So, because it's important to remember that the Cyrex arrays, 3X and 4, they're blood tests, right? They're not measuring. So there's two things to understand about them. They're looking at antibodies to the proteins. They're not measuring the proteins themselves, and they're blood tests. So this is going on in the systemic circulation. This is not measuring how much gluteomorphin you have in the lumen of your gut, right? If that's occurring on an intact gut wall as a breakdown product, this is going on in the systemic circulation, and it's not, we're not measuring the proteins, we're measuring antibodies to the proteins. So there's an immune component to it as well, when it's coming up on 3X and 4.
Actually, that's a pretty good, because if we're making antibodies to it, then the chances are it got across that barrier.
Mm.
And if it got across the barrier, the antibodies are like the tip-off that something got across the barrier. It's that we're not used to seeing, because it's supposed to be broken down in the, so is it the antibody that's the problem to the casomorphin? I don't think so. I actually think it's a tip-off that it got in where it doesn't belong, because from my, now after reading this article, which talks about A1 and A2 milk, which we can talk about, guess who's only drinking A2 milk now?
From now on, you.
Yeah. And I got even found an Amish farm in Pennsylvania that makes A2 cheese. If I'm going to do A2 milk, I might as well do A2 cheese. That's harder to find. But I think everybody, and I mean everybody, should be off A1 milk. If you want to be a dairy person and you love your dairy and you love your cheese, and you don't want to give it up, man, you at least ought to be an A2 person, and we can talk about what that's about.
Yeah, let's talk about that.
I didn't know anything about it actually before this.
So I think the author of this paper might have written a book on A1 and A2. And because I think, is he Spanish? I think he's Spanish. And so I think it was in the UK. I think when he published it, it was relatively popular in the UK, because there was a point where there was a lot of conversation about A1 versus A2 among the nutrition population in the UK.
Oh.
I think it was directly related to the author of this paper. And so this paper then goes into a lot more detail.
Well, the thing that happened was he wrote the book, I think, in 2007.
Yeah.
And it got, acclaim, but a lot of people poo-pooed it because he made statements that needed more specific scientific research. But now in this paper, he quotes the research. Yeah. So it basically, his suppositions in the book that were, made sense and had some research, now have really been well researched. And so a lot of the stuff is confirming, and these articles are, the last year or 2 years, so they're very current and very scientific. So his ideas in that book have really been proven to be correct based on real hard science now. Yeah.
He's a smart guy.
Very smart.
Yeah.
And the idea on these papers, I think, is, and who has this amount of time, but I don't know how many references there are in this, but there's got to be 80 some references. Let me see the last
on the
number.
paper, 125.
Yeah. I mean, that's how many reference articles there are. Yeah. So if you know how you are and how I am, and we've talked about critical thinking, I haven't had the time to basically, when a statement's made and say, this is the article that supports that, to go into the article, but I intend to, because I want to start talking about this. I think this is a big, big deal. And one of the reasons why there's so much autoimmune disease, there's part of that thing that you said, oh my God, this, has to do with sudden infant death syndrome. And you can talk about that, but I mean, and then they start measuring this beta casomorphin 7 in autopsies on kids that have died from sudden infant death, and they find high levels. The problem scientifically is you can't go get a live kid and go do an autopsy on their brain to find out, or their brainstem to find out, but these levels are high in casomorphin. This particular casomorphin 7, which is the breakdown product of A1 cows versus Casomorphin 9, which is the breakdown product of A2 cows, and they're almost have nothing to do with one another. In fact, Casomorphin 9 probably has effects to help your blood pressure and one other thing, but they can't find anything bad about it. Whereas the breakdown product from A1 cows, which is beta Casomorphin 7, they can't find anything good about it. Nothing. So it's interesting.
Let's talk about A1 and A2. What did you learn?
Well, what I learned is that the original, first of all, we, as most people know, we didn't even start having cultivation and communities till about 10,000 years ago for humans. And actually, once we started bringing in, animals to start domesticating them and using them for farming, is about 5,000 years ago. So it turns out that the original cows that were where they started getting dairy, milk from cows, and using it, as a nutrient, was from cows that were from Asia and Africa. And those were the original cows, and they worked out. People seem to be doing well. They exported those cows evidently to Europe, and for whatever reason, mutations occurred. And the mutation was in this beta casein. And so, which is the precursor, it's a big protein that's in all milk. And so then when you break it down, basically it has just a couple different amino acid sequences. And what happened was the mutant had one sequence for beta casein, and the normal one, the one that was the original one, had a little bit different. So when you broke down the casein with this dipeptidyl peptidase 4, DPP4, it made different products, that little product, and a chunk that was from the new cow that had a different amino acid array that was much harder to break up at a particular area because of proline, produced this beta casein, Casomorphin 7, which is distinctly not good, whereas the original one makes beta Casomorphin 9, which is good and has a lot of salutary effects. That's the difference. So in their alleles, in other words, on different pieces of of messaging on chromosomes, and they're co-dominant. So the mother gives you one and the father gives you one. It isn't like one overwhelms the other one. They're both show up. So if you say, well, I have, one parent was an A1 parent, one parent was an A2 parent, I hope my kids are A2 kids, that's not the way it works. So you're going to have one gene's going to be A1 and another one's A2. So that officially is called A1 milk. That is not A2 milk. You have to have double A2s from parents that have A2 alleles. So, and the other animals don't have that, like other mammals. So that's why goats and horses and camels, and why you're probably okay drinking that milk, unless you have some other problem with milk, but other than casein, but they have the A2 casein. And actually, it's interesting, humans, for a very short period of time, evidently that the Casomorphin 7 is much more potent in terms of its effect on the opioid receptors. So it turns out, and for giving opioid effects and getting somebody hooked and getting them mellow. So I thought it was fascinating that human beings make, in their normal production of breast milk, make A2 breast milk, but not for the first day or two. For the first day or two, they make Casomorphin the kind that is the, A1, which makes this beta casomorphin 7, which is a much more potent in terms of like morphine or one of those things. And then they switch off after a day or two. So colostrum in the first couple of days, it's mainly A1. And the theory is it's to get the kid addicted to the mother.
Isn't that unbelievably fascinating?
Yeah, it's amazing. Oh my God.
The human body is just a source of constant.
And then they switch off. Then they switch off and use the one that's really healthy. But for the first, they go, no, I want you addicted to me.
Yeah.
I think it's unbelievable. I read that and I went, you got to be kidding me.
Right?
Is that crazy?
That's amazing.
Yeah.
The body's amazing.
Yeah.
Antibodies are dumb, but the body's amazing.
So I don't think the antibodies, so when you're looking at this and somebody says, well, I don't have antibodies to casomorphin, so I guess I'm just going to keep drinking my milk. Not as far as I'm concerned. Whether you got antibodies or not, if you're using A1 milk, your chances are, in some fashion or another, you're getting the casomorphin 7, not the 9.
Yeah.
I wouldn't do it. And if you got some like a family history, I was looking at the HLA markers for diabetes, for type 1 diabetes, which they now have pretty well mapped out, it looks like. But man, if I had an autoimmune family or something, and particularly any autoimmune, that I either had it or I had a family member and I was getting ready to have kids, there's no way in the world that I would be doing anything except for A2 milk. And I certainly wouldn't be feeding my kid formula with A1 formula, which is, my guess is almost all of it's A1 formula. Don't you think?
Yeah, no, I completely think. But so in Europe, they have more goat's milk formula. They've got more formulas. And also available in the UK. There's at least 2 different brands of goat's milk formula available in the UK, but it's not the most abundant one. But it's like in the US, it's very difficult. It's very difficult to get goat's milk formula.
Interesting.
It's only really cow's milk formula that's available in the US, and I know they're all just A1.
So I would say if somebody reacts to, like on array 10, there's goat's milks on there. Yeah. And what I thought was, well, if you have antibodies on array, let's say array 4 for casein or whatever, and then you have antibodies on array 10, or you just do array 10 and you got goat's milk, that's, has to do with milk. But what I believe it probably has to do with is nothing having to do with casomorphin, but some other part of milk, whey or whatever, milk butyrophylline, that is consistent with milk, but having nothing to do with casomorphin, because goat's milk casomorphin is different than the one we have.
What about casein? So if alpha and beta casein come up positive on array 4, I tell people, don't try to play lawyer with the immune system. Like, that's no animal dairy. But is there, casein is casein is casein? That's not true. We know that's not true. But I feel like you and I have talked about this before. If the stakes are high, someone's got neurological autoimmunity or autoimmune disease, or it's a child, and we don't have all the information, sometimes we need to err on the side of caution.
No doubt about it.
Because at the moment, we can't differentiate really very easily or very well between, would this person react to mare's milk? Would they react to camel's milk? Would they, is it all casein, or is it just like, so if casein comes up, I'm like, look, let's just.
Totally agree.
It's such an interesting subject.
And then the gluteomorphin or the gliadorphin is very similar. It's not exactly the same, but it has the same, 2 or 3 amino acids that seem to be, we talked about the epitope, right? That the receptor binds to. And that epitope seems to be tyrosine and proline. Yeah. And they have that. The other parts they have in the other 5 or 7 or 9 things, but that seems to be the trigger to activate that receptor. So the difference is that when they've done these, these experiments, like in China, they basically, they can go, okay, we're going to do this one with A1 milk, and we're going to have this group do A2 milk. But with gluten, it's not like you either are eating gluten or you're not eating gluten.
There's no A2 gluten. Yeah, there's no A2 wheat. Right?
Correct. So it's harder from an experimental standpoint to do that. That's why I think the literature is not as good.
That's interesting. That's a good point. And to my knowledge, there's not a test just for casomorphin, right? Antibodies are what we've got, but antibodies is that next step. It's the immune response to the protein.
Correct.
It's not that it's the absence of antibodies doesn't equal the absence of the protein. It equals the absence of the immune response to the protein. And those two things are different.
And that's what I think people need to, I whether I get in trouble for this or not, but,
I can edit it out if it's really controversial.
Well, let's say, when you're looking at a perfect example is neurofilament light. Okay, that's an off subject, but it's a similar thing. Neurofilament light is one of the elements of neurofilament that really holds nerves together. It's one of the big, probably the most important element in nerves, particularly axons. And it's neurofilament as a neurofilament light and neurofilament medium and neurofilament heavy, chains. But the one that's measured is neurofilament light. So what they used to do is if somebody got a stroke or somebody had a concussion or whatever, they would, or maybe they just banged a mouse on the head to see what, and then they'd go in and check their cerebral spinal fluid to see whether this neurofilament light, which is part of all nerves, actually got out of the nerve where it doesn't belong and showed up in the cerebral spinal fluid. And the answer was it absolutely did. It was a very specific marker of nerve damage and nerve death, period. Probably the most specific of anything. So then somebody came up with the idea of, well, I wonder if we can't go spinal tapping every kid in a football game that gets hit in the head, right? So how are we going to figure out how bad that concussion was, or that TIA, for instance? And so they started seeing what the correlation was in neurofilament light amount, not antibodies, amount of neurofilament light with the serum. And they were that the correlation was like 1-to-1. I mean, it was amazingly good. So then they started looking at people, normal people, and going, let's do all these and see what the normal amount of neurofilament light is for everybody walking around. And then if somebody gets dinged, we'll check theirs and see if it's higher. And if so, does it correlate with how bad the injury was with how much higher their neurofilament light is? Because it reflects dying and dead nerves, period. Well, then we were looking on our test, on the Lynx test of neurofilament light is the last thing on the Alzheimer's test. And so my logical question, like you, since I'm not satisfied with that, and I know it's antibodies, I went, do those antibodies correlate with the level of, because the only way it gets out there is a dead nerve. Otherwise, it stays in the nerve. So do they correlate? Do the antibody level and the and the amount of neurofilament light in serum correlate? I just sent Vojdani an article the other day that I found that they do absolutely correlate. So that made me feel better. So
that's always a good moment when you get your question answered.
Yeah, well, you're looking at, there's the level and then there's the antibody. They're not the same thing. And there are people that look at this and go, well, this is the level. No, this is the antibody, which is going after something. So they're not exactly the same thing. So you need to be smart enough to figure out that they're not, and then wonder, do they correlate? And so that's what I'm always looking for.
All right. Well, another fascinating conversation, as always. Thank you so much. And I look forward to our next batch of questions.